All right, in this video, we're going to talk about how to use Google Sheets to make a graph. So the first thing you're going to want to do is go ahead and put your data into Google Sheets. So note that I just made up some data. I got the size of maybe a plot of land, and I just made up some sizes. This is in square miles. I have the number of cows that are on that plot of land, and I have the length of the fence to go around that plot of land. So important things to kind of note is that all my columns have titles. I have units in there as well. And then lastly, I don't have units in with my numbers. If you did that, then Google Sheets won't recognize it as numbers. So this is just some data that I made up as an example. You would have your own data. It very well could be the tumble buggy lab, it might be the circle lab. It could be, you might be watching this later in the year and just kind of remembering, to try to remember how to graph something. So that's that. So the first thing is you want to figure out what you want to graph. So for me, what I would like is I would like to have the size of the plot on the horizontal axis, the x-axis, and I would like to have the length of the fence on the y-axis. So there's a couple ways to do that. You could, if you wanted to, copy and paste those columns so they're all by themselves. You could do that. You can just use Control C and Control V to make that. That's one way to do it. I would prefer not to do that because I don't really want to start moving my columns around. It starts to get confusing, especially if you have formulas, which we'll talk about a little bit later. So I'm just going to go ahead and click Insert Chart over here. Don't have anything selected. And let's give it a second here. And there we go. Now, mine, because it knows me, has figured out that I probably want a scatter plot. However, yours very well might pick bar graph. For whatever reason, it thinks that we want to make bar graphs, which are dumb charts. So you want scatter plot. You always want a scatter plot. That's all we'll ever use. So you can just ignore the fact that there exist other types of graphs. So scatter chart is what you want. So if it doesn't say that, you just scroll on down until you find scatter and you click it. Okay, obviously my data is all kinds of jacked up over here, and that's because it's trying to graph a bunch of different things. So x-axis is what it's trying to plot on the x-axis, and series is what they call the y-axis. So that's what they're trying to plot on the y-axis. So we're trying to plot the size of the plot on the x-axis, which is what we want. And it's also trying to plot the number of cows and the length of the fence on the y-axis. I don't want the cows, so I'm going to go ahead and remove that. And you're right, so now it looks a bit better. Just in case, if it didn't say the right thing, if it wasn't that easy to figure out, what I would do is to tell it what I want, I would go ahead and click it, and then click select data range, and then I would include the label and click and drag down. Same thing, if I'm not 100% sure whether the length of the fence is correct, right, either it gives me some some options here, which that's kind of nice, but I still would like to be in control. So I'm going to select my own data range and again, click and drag down, catching all that data. So there we go. Another thing that's always kind of good to do is double check to make sure your numbers match. So, right, these numbers seem to go up to about 5, and the bottom goes up to about 6. So that seems about right. And the length of the fence, the biggest number seems to be 11.3. This seems to go up to about 12. So that seems good as well. Oh, I must have missed 8. Anyway, there it is. So anyway, there you go. Now, the other thing we want to make sure is we have labels. So it automatically put in the horizontal axis label, but it did not put in the vertical axis label. So to put that in, I'm going to go over to customize, I'm going to go down to chart and axis labels. And from there, I can make some edits. So I could do, I can change the title of the chart um, versus sense. That might make sense. I might also want to change the vertical axis because that wasn't correct. I would want to change that to the length. So now I got some labels on there. So we always want to try to have labels. I Units are probably good as well. Yeah, cool. So there we go. We got that. So I guess I didn't say this at the very beginning, but usually the reason that you're making a chart is because you would like to write an equation. You want to find the relationship between data. So in this class, you're going to end up with lots of different, you know, lots of different sets of data, and I'll ask you like, what's the relationship between that data? What's the relationship between, where the tumble buggy is and how long it's been traveling for, something to that effect. And so, in this particular case, I don't have a linear line, right? As we look at this, it's pretty obviously not a linear line, and so right? I don't know that I could write an equation, which is what I mean by a relationship. I don't know that I could write an equation for this. And so, right, I know how to write equations for linear lines. And so what I want to do is change this graph into a linear graph so that I could write a relationship between the size of the plot and the length of the fence. So if you're looking at your graph and it's a linear line, then you're done, right? You can use y equals mx plus b and you can write an equation for it right then. So you might want to end up skipping ahead in the video to see how I analyze the linear graph that I'm going to get. But if you're looking at a linear graph right now, then and after you've plotted it, then you just need to write an equation and you're done, and you just need to skip ahead in the video to see how to do that. But in all likelihood, you're not going to have a linear graph, and so we have to go through a process of linearization. And there's a document that's going to be helpful. It's called the Patterns of Nature. This will probably be in the assignment or on Canvas for you. And basically it says like, if this is the graph that you're looking at, then this is the graph that you need, or this is what you need to do to get a linear graph. So if you have a linear graph, obviously you don't need to do anything to get it to be linear. If you have a graph that looks like this, you need to make a plot of y versus x squared, where y and x are whatever you have plotted on your x and y axes. So right, we have a side opening parabola. Our graph looks like that, and our x and y are, right, our x is the size of the plot and our y is the length of the fence. So we need to make a graph of the size of the plot versus the length of the fence squared. So right, the square of y is proportional to x. So and our equation is going to kind of look like that. So I'm going to go back to my spreadsheet and I need to basically get this column. I need to square everything that's in this column. And so I want to make length. I'm not going to put units with it because L squared is, I just don't want to put it there. It's kind of confused with area. So there's a couple ways to do it, right? Obviously, I can 4 squared, that's easy, that's 16. So I can just type it in 5.7. I'd probably have to get my calculator out, and I could just go through and do that for all of these, but that's a little bit cumbersome. There's an easier way where um, you can use the equal sign to make Google Sheets do the work for you, and it's a very useful feature. So basically what I can do is now I just need to write an equation, and that equation is going to be, I want to take whatever's in the length box, that box right there, and I want to square it. So shift 6 will give you the caret. I want to square it, right? So it went ahead and calculated the 16 for me. And the really cool thing about that, you might say, well, that wasn't really that much faster. Here's the cool part. I can just grab, see how there's this little box in the corner? I can just grab that and drag it down and it copies that equation to each one of those boxes. So it squares everything, right? So it said, oh, look, you want to take C8 and you want to square that, which C8 is that one. So that's why that's really useful. There's other cool things that you can do with equal signs. So for example, like if I wanted to know like what is the average of all of this, I could just click the equal sign here. I could hit somehow new, but right, I could just start to type average or some, I mean, there's a ton of them, or some or something like that. And then I can just drag, like highlight the area that I want to find the average for, close the parentheses and click enter, and it'll find the average of all of that data. So anyway, that's also kind of cool. There's a ton of those things, some, mean, all this kind of stuff. So there we go. We got our length squared data. So what we want to do is we want to make a new graph. So keep your original graph. We might want to make a new graph where this is on the y-axis, the vertical axis, and the size of the plot is on the x-axis. So I'm going to go back in and insert a new chart. Okay, this one for right now, I'll just put it on top. It's like it guessed what I wanted. That's cool. Okay, well, it's kind of annoying right now because yours might not guess that you want it. So again, if it guessed something other than scatter plot, you're going to click there, you're going to go down, you're going to click scatter. Right, for the x-axis, you're going to want to make sure that it's the size of the plot. I almost never trust it. So I would just click here and highlight the size of the plot data. So I always want to try to make sure that I am getting the right thing. For series, that's whatever it's plotting on the vertical axis, the y-axis. It guessed length squared. Again, that is what I want, but just to make sure, I'm going to click here. I'm going to click the little box here so I can select my own data just to make sure that it's correct. You don't necessarily need to do this, just have a lack of trust that Google is actually doing what I want. And that's cool because if we look here, it appears that it's a linear graph, and so that's great. The right, the labels are correct. If they weren't correct, you could go to customize and you could go to chart and access titles, and you would be able to change those there. Now we have a linear line. Remember, the whole goal of this is to figure out what the relationship between the size of the plot and the length squared is. So in order to do that, we want to add a trend line. Please don't add trend lines to not linear lines, right? Only add trend lines to linear lines. So to do that, you're going to go down to series. Yep. Okay, so under series, I'm going to go down. I'm going to click trend line. Okay, added the trend line. I'm going to scroll down a little bit. It's a linear line, so that's good. We'll always only use linear trend lines. And label, where it says none, I'm going to say use equation. And now let's put that little equation right up there. And so that would be our relationship. So now remember that, so this might be a y equals mx plus b equation because it's a linear line, right? But remember that what that really means is length squared. So length squared, the length of the fence squared, equals 16 times the size of the plot. And we do have a little bit of a y-intercept that should, in theory, be pretty small. So there you go. That would be how you would find the relationship between those. So, and how you graph something. So you feel free to always come back and reference this, and so that you can, if you forget how to graph something, but we're going to use Google Sheets a lot for graphing things. So it's a useful thing to kind of remember how to do. So, all right. Thank you very much. Hope this helped.